Good morning, everyone. Today I will be presenting a comprehensive clinical overview of a highly fatal mosquito-borne viral zoonosis, which is Eastern equine encephalitis. We will walk through the complete clinical picture today, starting with the etiology and pathogenesis, moving through clinical signs in both equine and human patients, and finishing with diagnostic management and why this disease is a critical public health issue. Starting with the etiology. The causative agent is a single-stranded RNA virus belonging to the genus alpha virus within the family Tugaviridae. Clinically, a vital characteristic for us in the field is that the virus is immunologically distant and extremely fragile post-mortem, which gives us a very narrow window for accurate sampling. The natural reservoir is primarily passerine birds residing in freshwater swamps, while horses, humans, and other mammals are highly susceptible. They are considered dead-end hosts. This means they suffer severe disease, but their viremia is insufficient to maintain the transmission cycle. The transmission operates in an enzootic cycle between mosquitoes and birds, but spills over mammals via bridge factors, specifically Aedes and Cloax mosquitoes that feed in both. This disease is highly seasonal, with peak endurance occurring in mid to late summer. Let's trace the pathogenesis. Following the arthropod bite, the virus undergoes initial replication locally, leading to viremia and biphasic fever. However, the defining trait is its strict central nervous system tropism. Once it crosses the blood-brain barrier, it causes massive neuroinflammation, severe neuronal necrosis, and apoptosis, resulting in catastrophic encephalomyelitis. In our equine patients, the incubation period is 2 days to 3 weeks. The early phase presents with a high fever of 39 to 41 degrees Celsius, anorexia, and profound depression. This rapidly progresses with days to neurological phase, marked by ataxia, head pressing, and cycling. Before reaching the terminal sleeper stage, this final stage is characterized by a sawhorse stance, chimpanzee and Caesar, with a mortality rate of 40 to 80%. Actually, it's vital to recognize that the human infection follows a complex progression. While the initial systemic phase includes adroct fever, chills, and malaria, the central nervous system is ultimate target. If a neuroinvasion occurs, it triggers a severe, often fatal encephalitis characterized by focal neurological defects, seizure, and coma, frequently leaving survivors with permanent disabilities. Because early clinical symptoms mimic common illness, field diagnosis often relies on endemic seasonality and Definitive antemortem diagnosis requires detecting specific IgM antibodies via culture ELISA in serum or CSF. Postmortem confirmation relies on PCR or detecting severe necrotizing polioencephalomyelitis. But remember that brainstem or cerebrum samples must be shaped, refrigerated to perceive the virus. Currently, no specific antiviral drugs exist. Therapy is strictly supportive. Management focuses on IV fluids, and osmotic diuretics to manage cerebral edema. Therefore, prevention is our primary weapon. alongside aggressive vector management, we fortunately possess highly effective formalin inactivated vaccines for equals. We must strictly adhere to a schedule for 2 initial doses administered 10 days apart, followed by annual boosters. 40 to 80%. That staggering mortality rate in our equine patients is a massive red flag, signaling a high potential for fetal illness in humans because this is a deadly zoonosis. Our equals serve as a critical essential species. Equine cases act as an early warning system, triggering mandatory reporting and aggressive public health response to protect our communities. Thank you all for your time. I am happy to take any questions.